3. Testing 1, 2, 3. Welcome everybody. This is the Arduino from the ground up session brought to you by the lab.ms. We are Plano's makerspace. This is our first session in our education series, and hopefully we'll have a lot more coming up in the near future. So this is the absolute beginner's guide to Arduino. So we're just going to be covering all of the very basic material about Arduino. So a little bit about who I am. My name is Andy Michaels. I am Lego on Slack. I break things for a living, and I'm also the coordinator, the fundraising coordinator for the lab. I've been in the software industry for about 20 years, a little bit over 20 years, and I've had just enough electronics and hardware experience to be dangerous, so I can blow things up pretty well. And this is one of my favorite cartoons about programming. I go through this cycle several times a day. All right, so what are we doing here today? We're going to be introducing the Arduino to you. We're going to connect and communicate with an actual Arduino board. We're going to use the Arduino IDE software to modify and load an example program on the board. And hopefully we're going to have a lot of fun doing this. And then at the end here we will create a custom circuit so we can see how that works a little bit. Nothing too fancy. Okay, so what is the Arduino? The Arduino is an open source platform for electronics development or prototyping. So it's intended to be relatively inexpensive and allow you to add interactivity to various things. It is what we call a microcontroller. This same piece of hardware 25 years ago would have been considered a personal computer level power, but now it's relegated to very small environments. So what is a microcontroller? You can think of a microcontroller as a very small computer. Its main purpose in life is to interact with the world around it. So for that reason, it has lots of what we call input-output, or I/O. And so you can communicate with things like sensors, lights, just all kinds of things that happen in the electronics world. And the idea there is that you can have a low power consumption device that controls all those things. And if the device is small enough, we can embed those things into things like costumes, portable electronics, pretty much put things anywhere. And the other salient feature of microcontrollers is they're typically programmed from another computer. So in this case, we'll be working on a PC, writing our code on a PC, and then sending it over to our Arduino. So what does this Arduino software look like? So the Arduino IDE is a graphical user interface. It's got a fairly clean and simple interface. There aren't a whole bunch of buttons. There's not a whole lot of menus either compared to some of the other software development tools that you might see out on the market. There are lots of pieces of example code that come with the Arduino IDE, and if there's not something you're looking for in there, you can go out on the internet, and there are just thousands and thousands of pieces of software that you can find that either do the thing you want to do or get you pretty close and you just need to make some modifications to it. And these programs that we write in the Arduino IDE are called sketches. All right, is there something simpler though? Yes, there is. There is a tool called Tinkercad, and it was originally designed as a 3D modeling tool, but they've added this Arduino simulator to it. And what's great about this Arduino simulator is that it is a complete graphical environment. You can even do visual programming. So rather than writing lines of code like we saw in the last slide, you can actually use blocks. These code blocks. And if you've ever seen Lego Mindstorms or Scratch that they use to teach kids how to program, it's very, very similar to that. And so you use these different structures, and they only fit together certain ways, and it makes sure that you do things the right way. It's a very easy way to approach programming in Arduino if you've never done any programming before, or even if you have, it's actually a very convenient way to do that programming. And then what's nice is that you can then export that program as actual Arduino code. So in the image there, you can see on the far right is the Arduino code that correlates to the blocks the block sequence that you see in the middle there. So that simulator is really cool. It's got all the components that you might need to create a circuit. You can see in that drawing there is there's a potentiometer with that knob there, and there's a button and a resistor. So it's got all the components that you would need to create a circuit. It generates real code, and the great thing about it is you don't have to buy anything to use that. So if there's interest in this, next time I'll do a class just going over the Arduino simulator in Tinkercad. If people think that's valuable, we can do that. And again, there's lots of tutorials in the Tinkercad site for that. So if you're looking at this and you think, oh, I don't want to buy a bunch of stuff and I don't really want to learn the programming the traditional way, Tinkercad's a great way to go. So what can we do with an Arduino? There really aren't a whole bunch of limits. You can do things like powering your costume. So let's say you've got if you're a costumer and you want to add some interactivity, like a sensor, like a proximity sensor that then lights up some lights or some sort of display on your costume, that's something that you could do with the Arduino. You can control the lighting on your aquarium. I was actually working on a project to do that. I never finished it, but that's the story of my life. I'm sure some of you can relate to that. You can gather sensor information for solar car, and we are actually doing that. The slides that I showed you before are some code from, or actually I'm not sure if that's from the solar car, but anyway, one of the members of our solar car team had never approached programming before, and so we got her started with that Tinkercad solution, and now she is writing code that will read sensor information from the solar car so that we can show data to the driver. So there's quite a range of things you can do with this. Besides physics, there aren't a whole bunch of limits to what you can do. All right, so the anatomy of an Arduino. What are the parts here? So if we look at the top left connector there, that is a USB plug, and that is the device, or that is the host end of a USB, a host end type USB port. And so you would plug the fat side of a printer cable basically into that end, and then the flat part goes into your computer. On the bottom left, we see the 9-volt barrel connector. So if you want to move your project away from the computer, you can power it from a 9-volt battery. So you can connect that 9-volt battery with a little adapter that has a barrel connector on it and plug that in right there. By the way, when you do plug in the USB to your computer, the computer powers the Arduino for operation. So if you're just connecting to your computer, you don't need to worry about power for the board itself. Along the top edge, we see the digital input-output pins. This is where you connect things like your sensors and your output devices like displays or lights or other things like that. Along the bottom, we see another row of pin connectors. On the left-hand side, we see, well, I guess going in a few pins, we see 3.3 volt and 5.5 volt. So those pins allow you to get power for a little device that you might be connecting to your project. And then there's a couple of ground pins there, so you can complete that circuit. And then on the far right bottom, we see the analog pins. And those are for devices that return analog values. So things like a light-dependent resistor, stuff like that gives a voltage rather than returning a 1 or 0, a digital 1 or 0. You can connect those there. Now, what's interesting to me about this is that a lot of times people will have the conversation about the difference between a Raspberry Pi and an Arduino. And one of the advantages I see to an Arduino is that it has these analog pins. All the input-output pins on a Raspberry Pi are digital, and so if you have a circuit where you want that analog signal, you would have to add an analog to digital converter to a Raspberry Pi for that to work, or come up with a different solution like an RC circuit. All right, how do we get started? Well, first of all, if you don't want to use the Tinkercad, or if you're working on a project for the real world, you need to get an Arduino. Micro Center, if you are fortunate enough to live in a U.S. city that has a Micro Center in your city, it's a great source because they have pretty good prices on their brand of Arduino boards, and they are called Inland. And some people look at them and say, oh, they're knockoff Arduino boards. Well, they're not really knockoffs, and we'll talk about the licensing a little bit later, but they are actually real Arduino boards. So once you get your board, you need to download the Arduino software, or you can use the web-based editor. The web-based editor, I've not used it, but I know that there are a couple of people in the last class that had pretty good luck using that. But if you're more comfortable using desktop applications, you can just download the Arduino software from the link there. So once you get that set up, you connect your board, try out some of the example sketches, and we'll be going over one of those today. And then once you kind of get that running, then you modify it to do your bidding, whether that's good or evil, hopefully for good. And then the workflow. So once you got all this stuff connected and it's all working, how do you develop your code? What does that look like? So first you will be creating a sketch, and so that's writing code on your computer. Then you compile it and transfer it to the Arduino, and that's done with one button usually. Then you'll see it run, and then you will most likely see it fail because it's an iterative process. You're going to make mistakes and so on and so forth, and then you basically just repeat that process. There usually is cursing involved. Whenever I do programming, there is almost always cursing. So that is basically up to you how much cursing will be involved. So which Arduino is right for my project? First, some of the main factors that you need to think about are size, how much input-output you're going to need, and how you're going to power the project. This isn't an exhaustive list by any means, but these are probably some of the first things you should think about when figuring out what it is you want to, or when trying to figure out which Arduino you should get for your project. Let's see. There are quite a range of sizes. There is the Arduino Uno, which is the typical size. It is a credit card size board. There's the Arduino Mega, which is about twice as big as that, and it's got a lot more input-output pins. And they go all the way down to the, I believe it's the Gemma, which is about the size of a quarter, and it has about 5 or 6 I/O pins for it. And you can actually run that thing off of a coin cell battery. So there's quite a range of things you can, quite a range of boards that you can choose from. All right. Okay, so earlier I alluded to the idea of open source, and why is open source important? I am a big advocate of open source, and it's for these big reasons. First, you have your licensing. So the Arduino is built around the Creative Commons Attribution Share Alike license, so you can use it for personal and commercial works. As long as you give credit in your license to Arduino, and you release your designs under the same license. Another major selling point for another major factor that makes open source important is that you have ownership of your creation. So you don't have to pay licensing fees. You don't have to be beholden to someone else because you use their software to build your tool or because you use their design. All of this stuff is open, and you can use it pretty much any way you like. And the third point is one of my favorites because this has happened to me several times over my career. Vendor lock-in. So if 10 years from now the Arduino Foundation goes out of business, their software should still be available. If I have some old code that doesn't run in the latest version, I can go back and find source code for an older version of the thing and get my stuff to work, and then do the work to make it updated for the newer version. I have run into several situations, typically with like video codecs, where I can no longer view my content because no one has licenses for those codecs anymore, or other pieces of software that have expired, or people have stopped supporting them. So these are reasons why open source is important to me, and they might be important for you. All right, let's see if we have any questions over in the stream. I did a bad job of keeping up on the stream over there. Let's see. Can I link Sublime Text to this IDE? Warlock7777. I don't know. I have not used Sublime Text. If anybody knows the answer to that, you can at Warlock7777 in here. Let's see. Let's see what else we have. if I use an Arduino in my Destructo bot, I need to release all designs pertaining to the bot itself as well. You should train your power up. That's probably good practice. It does increase the chance that someone's going to stop your nefarious plot, but those are the risks you take as an evildoer. So yeah, that's probably going to happen. All right. Okay. Doesn't look like there are any other questions, so let's dive in. All right, so this section is going to be the hands-on portion. And these are usually two different sessions, but I'm just kind of combining them all into one. So typically, here's what you'll need. You'll need a computer with a free USB port. This is designed around doing in-class, and so we provide kits. Not having USB-C is not really a big deal if you're doing it on your own computer. So you could do USB-C to USB if you like, that's fine. It's just that the kits that we have don't have USB-C cables. An Arduino board, a USB cable, some type of breadboard, some jumper wires, an LED, and a resistor. And you can see I've got all of those things here in my workspace, so I am all ready to go. So I've got my Arduino board, I've got my USB cable, I've got my breadboard with a button handily attached there. We may or may not get to that button. I've got some jumper wires. I've got a blue LED because I like blue LEDs. And then we've got a 1K ohm resistor here. And we will get down to business here in a little bit. Okay, so we've got everything we need. You need to download the Arduino software. So if you're following along at home, this would be a good point to go ahead and grab that software if you haven't already. And as I talk, you can get that downloaded and installed. And then once you got it downloaded, install it, and I'll go through the setup here. All right, so once you've got all of your things connected here, we can do a couple things. Let's go back over. All right, so first, let's connect our Arduino board to the USB. So I've got the USB cable connected to my computer, and then I'm going to plug it in to my Arduino board. And you can see that it's doing something with the LED there. It's basically just going to run whatever code you had on there before. In this case, it had the Blink program on there. So we've got that all hooked up. Let's see. Now we need to go back and we need to select which board we're using. We need to set up our IDE so that it is talking to the correct device. So we have the Arduino Uno. And so let's go now to our over to our IDE. All right, so this is what the Arduino IDE looks like. And I've opened the tutorial, the Blink tutorial. So when you start up your Arduino IDE, it'll usually start up in a very, very tiny window. I expanded this so that we can use the screen, and I made the text a bit bigger so everyone can read that on the stream there. The first thing we're going to do is we're going to tell the Arduino IDE which board we have. In this case, it's already set. I think the default is Arduino Uno. But if you have a different board, you can select that from this list, and there are quite a few in here. And if you have a board that isn't listed here, there are typically tutorials on how to add that board to the Arduino IDE from the vendor where you got that board. The one I can think of off the top of my head is Adafruit. They have very, very good tutorials on their website for all of the products, and they have really good integration with the IDEs and things like that. So we've told the IDE which board we're using, and now we need to tell it which port that board exists on. And in this case, I've only got one port, and it's connected to my serial port. And on Linux, these are named very oddly /dev/tty acm0. If you're using Windows, it'll typically show up as something like com1, com2, depending on what configuration your computer has. And on Mac OS, I believe it uses a similar naming to Linux, but the names of the devices are a little bit different. Let's see. All right, so we've told Arduino IDE that we're using an Arduino Uno, and we've told it which port it's on. So now we should be able to communicate with it. And by communicating, what we're doing is we're sending our code down to that board. So I have opened this Blink program, and the way you open these sketches is to go to the File menu, and you can go to Examples. From Basics, you can see Blink. So select that, and it will open up this file. and it's got some nice documentation in the form of a comment up here. And what this board does is, or what this sketch does, is that it's going to blink the built-in LED on the Arduino Uno. And you can see that there are two sections here. There are two what are called functions. The first is called setup, and the second is called loop. So setup gets called when the board starts up. Setup gets called, and it executes everything in here once. So things like setting up your input-output pins for some for input, some for output, creating some basic variables. That all happens in setup. And then the loop, once the setup is done, then the loop function takes over. And basically loop does exactly what it says. It loops forever. So it just keeps going over. So it executes all the instructions inside the loop, and then it goes back to the beginning and does it again. So it's kind of like, for those of you who are new to programming, it's like when you see the shampoo bottle, it says lather, rinse, repeat. That is an endless loop because it never tells you when to stop, right? So that's what the loop does here, is it's just going to keep going and keep repeating these steps over and over again until you take the power away from the board. All right, so let's see, what is it doing here? In setup, we're calling a function called pin mode, and we're setting the LED built-in pin, and we're setting it to an output. So then in our loop, what we're going to do is we're going to write to that pin, and we're going to set it high, which means to turn it on. Then we're going to wait a second. Then we're going to set it to low, which means off. And then we're going to wait a second. So we're going to turn the LED on, wait a second, turn it off, wait a second. Then we loop back to the beginning. We turn it on, wait a second, turn it off, wait a second. And that's going to just keep going forever. So if we go over, or actually, if we want to do an upload here. So along the top, there are several buttons. The second button from the left is the upload button. And so what that's going to do is that's going to take this code, it's going to compile it into something that the Arduino understands, and then it's going to send that code over to the Arduino. And if I didn't make any mistakes, we should see done uploading, and so that worked. So now let's go over to our board and see what it's doing. Okay, so we can see that the LED, that's the built-in LED, and it is indeed going on for a second, off for a second, on for a second, off for a second, over and over. Great. So that's so what we've done. We've connected the Arduino to our computer. We've set up the Arduino software to communicate with that board. We have taken an example program, and we kind of understood what it did, and then we sent that program over to the board, and we see that it is in fact doing what the code told us it was going to do. All right, so now let's see. Okay, let me check and see if there are any questions over here. Let's see. Warlock, at some point, will you discuss connecting boards to projectors, audio equipment, etc.? Not in this session. This is just real basics. In fact, we're pretty close to being done, but that is something that we can talk about. If you want to talk a little bit more, put a little bit more detail about what it is you want to connect to there. I can cover a bit of the audio equipment. So we'll get to that a little bit. Oh, okay. The 7s are silent. Okay. I just got that. Thanks. All right. Okay. The pop-up menus aren't visible. Yeah, I am using OBS. Let's see. The pop-up menus from the app aren't visible. Oh. Let's see. Not sure which pop-up menus you're referring to, but I'm really just using the let's see. Let me see. So I've got the file menu open here. Let's see if that is working. Oh, interesting. I wonder if that's okay. So I apologize. For some reason, OBS is not seeing the menus come down. So yeah, yeah, I'm not sure how to pronounce that. SIAGEH. GAH. Yeah, it looks like it's probably an issue with Java components or something like that. I will take note of that for next time, so we can take care of that. All right. Okay, Warlock. Yes, just trying to wrap your head around connecting and controlling external devices. Yeah. We'll talk about that in a few minutes. All right. So now that we've got a running example program, let's go ahead and change this. So rather than blinking for a second, let's do something like 250 milliseconds just to see that our change makes some kind of difference. So we'll change that 1000, and this delay is in milliseconds, so rather than 1000 milliseconds, we'll change it to 250, so it should be there for a quarter of a second. So we'll hit the upload button, and then we'll go back over to our device, and you see that it's doing a short blink and then off, short blink, off. So nice. Okay, now let's do something, let's see, is that? Okay, let's transition back over to the slides here. All right, so we've got all that stuff working. Okay, and then we just did this, we made the small change. So we changed the duration of the blink, we loaded it back onto the Arduino, and we saw that, that it was in fact doing something different. It did take our change. All right, so with that under our belts, let's make a custom circuit. So rather than blinking the built-in LED, let's blink an external LED. All right, so so what we're going to do is we're going to wire up an LED and a resistor on a breadboard, and then we'll connect to the Arduino to that breadboard. We're going to change the pin numbers in the IDE, or we could use the same one. So we'll start with the same one first, and then we'll do one small change at a time. And then we'll compile and load the new version, and then observe the result. All right, so let's do that. All right. Okay, so here's our Arduino. Okay, so this LED is on pin 13. I know you can't see that from there, but you can take my word for that. So what we're going to do is we're going to wire up an LED, and so what we'll do is we'll connect our. So we've got our handy breadboard here. So for those of you who are not familiar with electronics, I will quickly go over this. Every row, or in this probably looks like a column to you, is a single rail or a single connection. So anything in this row is going to be connected. So if you need the pins on something to be connected to two different rails, then you need to cross over those rows. So I want these LED legs to be one on one rail and one on another rail. All right, so then we will take two jumper wires. Oh, and then we also need, okay, so we're going to use, so there is a pin 13 on this connector. So we know that that LED is on pin 13, so we're going to connect pin 13 to some rail on the breadboard, and then you always need a resistor in the series with, or in the circuit with an LED, and I learned this the hard way, because while that LED will work without the resistor, you're eventually going to blow it out. For those of you who know me, you know that I made a Rick-rolling toilet, and it needed an LED, and it burned out at the least convenient time, and I didn't have a chance to replace it. So I learned my lesson by failing miserably and not heeding the wisdom of the ages. All right, so then we're going to connect the other end of this to ground, and if I have my LED oriented correctly, this will light up, and I do not. So the interesting thing about LEDs is that they are, since they're diodes, they are directional. So the electricity only flows one way, and I'm not going to get this to focus, but yeah, so you can see one leg is longer than the other, so that should tell you which way it goes, and I'm probably going to put this in wrong again. Nope, there we go, got it. All right, so now you can see that both the onboard LED and the breadboard LED are blinking at the same time. That's because they both operate off of the same pin 13. All right, so let's, so we don't actually need to load new code for that because it works because we didn't change the pin. But let's go back and let's actually make this light up. Let's make this use a different pin than the built-in. So what we're going to do is we are going to create a variable. We're going to call it my LED pin, and it's going to be an integer, some number, and it's going to be equal to 7. Let's say 7. Pick a number. We just need a number that is the same as one of the pins, and then everywhere it says LED built in, we're going to replace that with my LED pin, and then you go and make sure that my This is case sensitive, so if you're using camel case like I am here, you need to make sure that everything matches, or else you will get an error. So if I were smart, I would probably just do a search and replace, but you know, as you just found out, I tend to learn the hard way. All right, I think that's everywhere that shows up. Let's go ahead and do 500 for these guys. All right, so I've made my changes, and now I will hit the upload button. That's going to tell me if I have any errors in my code, and then it's going to send that code over to the Arduino. So I didn't get any errors. Oh, yeah, I just messed that up. I forgot to switch back over. All right, let's see, blink sketch. Sorry about that. Let me do that again. All right. Okay. So I'm going to create a variable. I'm going to call it my LED pin. And then I'm going to replace everywhere it says LED built-in. I'm going to replace that with my LED pin. And again, these are case sensitive. And again, I'm going to change these durations to 500 milliseconds. Okay, so let's try that again. Shouldn't have any errors. Oh yeah, I messed that up. All right, what do we do here? Yes, forgot to make that some value. There we go. Try that again. It's uploading. Okay, so let's go back over to our Arduino. And we should see that the onboard LED is no longer blinking. That's just on. Now, we told the Arduino that it should fiddle with whatever's on pin 7. So we need to move our orange wire from pin 13 over to pin 7. And now we should see that blue LED come on. And it's half second on, half second off. So there is our first custom circuit. We have deviated from the example in 2 ways. We changed the pin that the LED is on, and we changed the duration of the blinking for the LED. All right, let's see if we have any questions over here. Let's see. Can you? Okay. There we go. Okay. Yes, polarity. That's right, about the LEDs. Can't see the code. Yes, I screwed that up. Okay. Yeah, I had a confidence monitor. Well, I've got the Twitch stream up here, but it's since it's delayed, I don't always get it. Zoom in on the resistor placement. Yeah, let's do that. So let's take a look at this circuit a little bit closer. Oops. Okay. So. Okay. So we can see here, I'm going to move that there. There we go. So on the Arduino, the orange wire goes from pin 7 on the Arduino to some row on the breadboard. And then that same row, I've connected the resistor. I'm going to try to move my hand here. So the resistor leg is in the same row as the orange wire. The other resistor leg goes on the same row as one leg of the diode, or the LED. And then the other leg of the LED is in the next row. And then in that same row is the brown wire, and that brown wire goes back to ground on the Arduino. Okay. Okay. All right, that I think that covers all we have here. So let's go back to our slides here. Okay, so we made our custom circuits. Yes, so that's all the material. And again, just wanted to put in a plug for the lab. We are a local makerspace in Plano, Texas. So for those of you who are relatively nearby, come visit us. If you have never been there before, if you're not a current member, you can get in touch with us at leadership@thelab.ms. You can also join our Slack. So if you got here through the Meetup link, there should be a link to the Slack there. If not, I am going to put a link to the Slack here in the chat in a few minutes here. But yeah, support your local makerspace if you're not in Plano. They are wonderful places to learn, wonderful places to hang out and meet people who like to make things. So, yay. All right. Any other questions? Okay, it doesn't look like we have anything else in the stream. I'll hang out here for a little while. Oh, yes, I wanted to circle back to the question about interfacing with external things like audio equipment. So the Arduino itself doesn't do a whole bunch. So pretty much anything you want to do, you're going to need to connect some sort of other board. And Arduino uses the terminology of, I'm going to get this wrong, shields. Yes, okay. Raspberry Pis use hats and Arduinos use shields. And you can get an audio shield for the Arduino. And basically what it is it's a circuit board that is pretty much the same size as the Uno, and it it extends a bunch of pins that go into all of the I/O pins for the Arduino board, so that you can use some of those pins on top of the shield. So you can stack the shields and use those pins that you may not use for that shield. So it's a really nice system. You can end up with some really thick boards, but it's still pretty cool. Let's see. Okay. There. Thank you, Funkmaster, for putting that Slack link in there. Let's see. So for the audio, there is an audio shield which will have an amplifier on it, and I think it has a 3.5 millimeter stereo output on it. So typically, due to things, unfortunately, those boards are a little bit expensive. I think they're $25 for those audio boards. So a lot of times in some of my solutions, I'll just go ahead and use the Raspberry Pi because it has some of that stuff built in. But if you want to stick with your Arduino, there's a shield for just about anything you need. There are some shields that combine functionality. You can get a shield with an Ethernet port. You can get shields for SD cards. You can get shields for just about anything. I think I had at one point a motor controller shield, and that was nice because you could add extra power to that. So you could power the motors from an external power source, and then all the logic would be controlled from the Uno. All right, so let's see. Going back over here to the questions. How do I make a motion sensor that will turn on a light or play a sound when my hand moves? Yeah, that's a good question. So basically, you would need that motion sensor circuit, or you could get a little board that has a motion sensor on it, and then you would connect that to the right pins. And a lot of those breakout boards, they'll be either SPI based or I2C based, and those are two different types of connection protocols that you can use for connecting boards to boards or chips to chips. But those are fairly handy. There's also UART, which is basically a serial protocol. And some boards use that as well. But basically, the documentation that comes with some of those breakout boards will tell you where to connect it, and then they'll give you some sample code on how to read the information from that sensor. And then once you've read information from that sensor, you write code that will figure out what to do with it. So in this case, you would read trigger values from the sensor, and then when those trigger values meet certain conditions, like it's greater than certain values, or if it's a digital signal, you'll see that it toggles from 1 to 0 or 0 to 1. When that happens, and you can detect that happens in software, you can then do something like turn on a light or play the sound like you had mentioned there. Can I fire sounds, loops in Ableton, Reason, etc.? That is a really good question. Yeah, so if you want to connect this to your PC, I think you can actually do some of that stuff over the USB port. I'm not sure how much you'd be able to do that over the USB port, but you can do some. If you have something like a control surface that you would use as something like Ableton, or if you even have like an analog synthesizer that has CV ports on it or CV pins on it, you could use those to trigger signals on the Arduino and do that. Let's see. I'm not sure what Resolume is. I've not heard of that one. I know Ableton and Reason. Let's see. How does it work to connect to, say, just a regular light bulb? Yeah. So if you wanted to control a light bulb like on and off, what you would need to do is you need to power that light bulb externally, because it'd be 120 volts AC. So you would need that would need to be powered externally, but then you could use what is called a relay, and then that relay would control basically a switch to tell that circuit to go on or off. And then the control for that relay would be controlled through the Arduino. And then let's see, how does it work to connect stage or level electric? Yeah, so if you have Christmas light string, same thing. So you could have those plugged into an AC power source, and then somewhere between the string and the power source, you need to put a switch with a controllable relay there, and then you would connect that relay to your Arduino, and then you would write some code that would it could detect things like time of day. It could be like a light sensor. So when the ambient light values get below a certain amount, you can switch that relay on, and that'll turn the Christmas lights on. Okay. Any other questions over there? These are good questions. Let's see. Yeah, maybe we'll do something like that in a future session. And with the holidays coming up, we could do the Labo Lantern again. Okay, so relays are where I need to interact with real world stuff. Relays you'll need if you want to switch things on and off that are powered by something else. So in the examples that you gave, like those electric lights, since they're AC equipment, you can't control the AC itself through the Arduino, but you can control a switch that turns it on and off. Yes, CXCAC has a good response there. All right. That's the end of the material that we have. I have no problem sitting here hanging out for a little while if you guys have questions or want to chat on the chat. But I will take audio off for now. I'd like to thank everybody, and again, I'd like to thank the lab for this opportunity to present this material.